Today's video will explain the relationship between different design views. Hello, I'm James Helfrich. There are many different design views. There's a structure chart, there's a flow chart, there's data flow diagram, there's a class diagram, there's a sequence diagram, there's a component diagram, there's even an entity relationship diagram. What are these different diagrams? How do they relate to each other? And how do we use them to come up with better designs and to communicate design ideas? This video will explain this. There are so many different ways we can represent design ideas. You can use a flow chart or pseudocode. We can use a structure chart or a data flow diagram. We can use a class diagram or a component diagram. We can even use a state diagram. The big question is, what viewpoint do you use and when? The first researcher to discuss this was Philip Christian back in 1995 with his 4+1 view model architecture. And in there, he came up with four basic ideas of how to represent design ideas. The first is a logical architecture, and with this, you use class diagrams, object diagrams, entity relationship diagrams, and schemas. Then there's the process architecture, and here you use data flow diagrams, pseudocode, and flowcharts. And then you have the development architecture with component diagrams and structure charts, and finally, the physical architecture with deployment diagrams. Let's take a look at each of these in turn. The first step in the development process is to understand the big pieces. If the project is going to have more than one component, then a component diagram is a natural first step. So usually I'm going to start with something really big like this. I'm going to have a web portal and a mobile application, and that's me connected to a server, and the server is going to be connected to a database. Now, at this point in time, I really have no idea about the web portal or the mobile application or server, but then I'm going to zoom in, on this case, on the web portal, and I'm going to notice the web portal has these different subcomponents like account creation and login and system administration. Then I'm going to zoom in on those, and I'm going to zoom in on those until finally I understand each individual piece and how they relate to each other. Now, at this point in time, I don't understand how they work, but I do understand that piece needs to exist. And a component diagram allows me to understand the pieces and how they interrelate with each other. Now, step two is the data flow. Once the major components are identified and the subcomponents too, then describe how data flows through the system, tracks a data item from the origin to the resting place and finally back to the destination. Now, for an example here, the user on the left is going to send a request to the UI, and that's going to send an email to account recovery, which can send an email to the server. And then the server is going to come back with a Boolean success and a Boolean success, and then a confirmation to the user. So now I understand how the different things work together. Now, each of these processors is going to be a verb, which could be one line of code, or it could be 1,000 functions. We don't know. There could be of various sizes. Now, at this point in time, I also don't understand how the information is encapsulated or represented in the data store or in the processes. Here's a more complex data flow diagram. And again, we have 1, 2, 3, 4, 5, 6, 7 different verbs, from display to get to remove to register to select. And each of these things is going to perform an action. I'm going to have one data store on the right, session storage, and have one interactor left. And I'm going to understand how the data is going to transition between the different processors as it moves from the interactor, the user, all the way to the data storage, and how it gets back to the user. A data flow diagram is a really good way to understand how these different subcomponents work and how data interacts between them. I can also help understand a subcomponent with a UML sequence diagram. In this case, we can see the client sends a request to the controller, and the controller sends a sanitized request to the service, and the service is going to do some business logic and then send a sanitized request to the repository. This represents very similar information to data flow diagram, except I understand the sequence of actions and how one depends upon the other. So if that's a part of the design that you like to describe, then a UML sequence diagram is the one for the job. And here's another example of a sequence diagram between the user, the save, the database, and the server, and how information flows between them. Now, there's one other option we have for understanding and describing a subcomponent, and that's a UML component diagram. And here it's going to describe how data flows from the participant to the OS to the browser. But it's also going to tell me the order in which things happen, because each arrow is going to have a number, and that number is the sequence of events that happen from one to the other. Now, whether using a sequence diagram or data flow diagram or a communication diagram, each of these help us to describe a different subcomponent of the overall system. But it does not, at this point in time, describe to me how data is stored or how those processes actually happen. From there, I'm going to need something different. So step 3 is data storage. Now I've already identified which data storage requirements are required from my sequence diagram, data flow diagram, and even my component diagram. At this point in time, I describe their individual format. Now, if this data is in memory and at rest, then we usually use a class diagram. And the class diagram is going to show me the class name. It's going to show me the attributes or how we store the data, as well as the verbs that operate on them. It doesn't tell me anything how those verbs actually work. It just tells me that I need a function at this point in time called display or remove thread listener or create semester plans. It also shows me how one class is related to another class using these end caps, in this case, composition and aggregation, but I could have inheritance and subclasses and things like that. Now, this is data currently stored in memory. Sometimes I need to show data as it's stored permanently, and a database would be a good way to do that, and the entity relationship diagram would describe that. So I might start with an overall design. Here is all the different tables in my database, and how they relate to each other. But then I might want to zoom in on a specific table and discuss that and all the different, and this will show me all the different keys and rows associated with the table. Now, this is really great for the data storage part of the data flow diagram, but I also might need to describe how data moves between different components, especially across the network. And in that case, I might want to use a SQL query. For an example, here are 1, 2, 3 different SQL queries at how I'm going to update the table. Or you might want to have a JSON schema. And this is really useful for describing how I'm going to serialize data. In other words, turn in the text and move it across the wire from one process to another. And this is the format in which data is going to form. And this is called a JSON schema. Now that I understand all the different components and how they relate to each other, now we understand how data flows through the system. And now that I understand how data is stored and represented, the last thing to do is describe the algorithms themselves. And that is the final step to the process. So the first method we can use is a flowchart, and a flowchart is very good for decision-heavy algorithms. In this case, I have a very decision-heavy algorithm where I'm going to start at the upper left-hand corner and finish the bottom left-hand corner, or a pseudocode. And the pseudocode is useful when I have loops and other complex algorithms. Usually algorithms are the last step of the process, because I don't even know what algorithms I'm going to have to represent until I understand what they are through the class diagrams, the sequence diagrams, the data flow diagrams, and the component diagrams before that. So I drill from very general all the way down to very, very specific, and this is usually the last step. And it should be rather straightforward to convert some pseudocode or a flowchart into the programming language of our choice. You can learn more about this in the design view section of the design description chapter of the software design textbook.